You got to reprogram them, right? You got to go in, you got to say, okay, I replaced the battery. This is the information on the battery that we put in it, and that tells the computer, hey, you need to pay attention and now change your charging philosophy because it's got a brand new battery. Okay? Now GM is great. GM is smart enough because they have the current sensors and everything else on them that they reset themselves.
Yes.
GM is smart enough that they recognize, hey, something changed and I got a new battery and I can reset myself. You know who's not smart enough? Ford. 2016 and newer Ford trucks. You put a battery in them. What do you got to do? You got to reprogram them on Ford. 16 and newer Ford trucks. So, what do you think other manufacturers might be requiring in the near future that we've never seen before? The exact same thing. You know, these other manufacturers that we work on, they might start doing the same thing, but yeah, Ford, you got to reprogram the battery, just like a European. Just go in, as long as you know you got to do it. Because if you don't know, you reset your steam. Yeah. But what happens if you don't know? Guess what? You're putting a battery in it again under warranty. Yeah, it'll kill the battery because the charging, it'll charge it like an old battery. How does an old battery get charged? More, right? Old battery gets charged more, right? The new batteries like getting overcharged? No. What happens if you take your cell phone and you always leave it plugged in?
Oh, that sucker get on fire.
Kills that battery, right? Exact same thing happens to the batteries on the cars. You overcharge them and you take away the life of the battery. So that's really the thoughts behind it. So here we're looking at this. In this case, the amperage that the current sensor says this is drawing, and it is charging, we're at 13.8 volts, is 2.48 amps. Is that good or bad?
That's kind of normal.
Tell you what my answer is. I don't know.
Is
I
that
don't
normal?
know. How would I know? Well, might be able to go look it up and know data. Maybe. But a better way for me to know? Look at some known good cars as part of my regular servicing of cars, so I start to get an idea of what I should be looking at. If I know what known good is, then when known bad shows up, it's going to jump right out and bite me, right?
Right.
Oh man, I got a muscle cramping up on me here. Testing voltage to the computers. How many of you guys, as part of diagnostics, when you're doing diagnostics for intermittent problems or any problems for that matter, you're looking at what the modules say they have feeding them versus what you tested the battery? Yeah, this is a quick and easy thing to get an idea of, hey, I might have a voltage supply issue. I'm not going to say that for sure that it's going to show you have a voltage supply issue, because it might say that you have fine voltage and you still have a voltage supply issue. But if it says you don't have good voltage, then guess what you definitely have? A supply issue, right? All right, now let's talk about voltage drop testing. Who can tell me how you voltage drop test a circuit in a car? Not you.
A draw test?
You guys have too many answers. Who can tell me how you voltage drop test a circuit in a car? Anybody?
A draw test?
Nobody? All right, do you guys know the answer? How you voltage drop test a circuit in a car?
Well, you're doing the positive side, or you should go from the battery terminal to whatever component
Okay.
to see if I'm getting a reading on the meter.
Okay.
If any voltage is bleeding through to the reading.
Okay. What condition does that circuit need to be in for it to be tested? What condition does that circuit need to be in for it to be tested?
Needs to be active.
It needs to be active. Okay, so voltage drop testing is testing from one point to another point in the circuit on the same side of the circuit. So positive to positive, negative to negative. The circuit has to be active. There has to be current flowing through that circuit to do the test. If there's no current, the test is not accurate. And then you're looking whatever you show on your digital voltmeter, because you have it set for volts. You got 1 point to 1 point to the other. The best example that I like to give is positive on the battery to positive on the top of the fuel pump. And whatever it shows is what you're losing in that circuit. So let's say I do that test on the fuel pump, the car is running, and I show 4 volts on my digital voltmeter. Car's running at 14 because it's charging. I have 10 volts supplying to that fuel pump. The fuel pumps like 10 volts.
Nope.
No, they don't. They do not turn at the right speed if you are only giving them 10 volts.
Can you go to alternator?
Yeah, you can go positive on the alternator. That is a very important test. Same thing, positive to maybe positive on the starter. Okay, and anywhere in the circuit is, again though, it has to be active. And there was something I was going to say, and I totally got distracted now. I can't remember what it was. Oh, yes. Okay, so that same test that we're talking about at the fuel pump that we show 4 volts of lost voltage. Now, if we went and we tested voltage at the fuel pump with our digital voltmeter or maybe our power probe or whatever it is that we want to use, we might see 13 to 13 and a half volts. Because we have voltage, but the problem is that under a load, when you are loading that circuit, it can't hold that voltage with amperage running through it. So you might show voltage is fine, or maybe a little bit low with a regular tester when you're just testing voltage, but the reality of it is no, it's not fine. That's why you want a voltage drop test stuff. Voltage drop tests on grounds. You know, chassis ground to negative at the battery. You should show nothing basically. In fact, the reality of it is you should show basically nothing on just about all of these tests. I'd say the most that you should see realistically is about half a volt if you're doing a long test. So, like that fuel pump. If I'm going that far with the fuel pump, maybe I'll see a volt, because we're going through a relay, maybe a couple connectors, we're going through some wire, maybe half a volt. I would consider normal on something that long. But most of the circuits that we're going to test aren't going to be that long. They're going to be a couple feet in length, maybe 1 connector or something like that, so we shouldn't see very much voltage drop. And the other thing is that's maximum voltage drop. Okay, there's going to be a point where and I think it's in your books, that lists out like how much each connector should have max, how much a relay should have max, how much wire should add to it max. But the reality of it is you should have very, very little voltage drop when you're testing these circuits. So the next thing I ask is, you know, how do you test your powers and grounds? You can't test powers and grounds with a test slide. You can't test powers and grounds with a power probe. Except for the very new ones, but we're going to take those out of the equation here. The new ones have some extra testing built into them, but the reality of it is you need to load those circuits. So how do we load it to test it? Go, headlight bulb. I think most of us have headlight bulbs in the shop, so I usually go into my shelf and grab maybe like a 9003 or something like that, because it's got blade connectors to it that I can just hook up my leads to it, and that's what I go and test with. So I'm loading that circuit with a headlight, which puts a pretty good load on it. And if I have a nice bright headlight, then my power or my ground, whatever I'm testing at that time, is good. Okay. Any questions on that? Because I think that it's something that most of you didn't really know about. So are there any questions?
My thing is, when y'all see y'all going to class, are y'all cutting the circuit the way you run it in series, or you just taking your lead from one to what, and what set
Okay, so you leave the circuit how it would normally be and throw flow current through it. If you can't force the circuit to flow, so if you can't turn that circuit on to be able to do the test, you can disconnect the ends and send your own feed of power through it and hook it up so that you're feeding your own power through it. You would need to put some kind of resistance, like a headlight bulb, in line to be able to do that. And then you can feed power through it to test your wiring connections and everything that's basically there. But ideally, you want to leave that circuit connected and let it run how it normally would. You're taking your digital voltmeter on the voltage setting, and you're touching one lead to one part of that circuit on positive, and the other lead to the other part of that circuit on positive. So positive to positive with your two leads on the volt setting. Does that answer your question?
Yes. Okay, because I'm thinking, how you do it. Well, I'm thinking about amp flow and all that. All right.
All right, any other questions? Nope, all right, now let's continue. So I think this is the battery tester you have, right? There we go, that's it. So we already talked about this, I'm not going to beat it to death anymore. So, let's talk about this. What is the noisiest circuit, the noisiest part on the electrical system in a car?
Oh, hey.
Any other guesses? Because it's not the alternator.
Is that?
It's
Not
the
the
AC.
alternator. Starter.
Oh.
Starter is the noisiest component on a car in the electrical circuit because it's a direct short to ground. It is a direct short to ground. All right. Let me give you some examples. Nissan comes in. Customers complain. Has an extended crank. Extended crank on a Nissan. I know where my first thought is and where I'm going to test on this. Where are you guys going to test on to begin with? What do you think? I'm thinking of fuel pump, right? I'm thinking the check valve on the fuel pump is bad and it's bleeding down, right? Come on, we've seen a million of those. So we test it because I think that's where everybody would go. It tests fine. It's not a fuel pump issue. The actual problem on this is the starter. The starter is causing too much noise when it's engaged. And it's causing so much noise that it is actually covering up the crankshaft position sensor signal. Wow.
Is that
Until it
primary?
starts to rotate a little bit more freely, because we know how cars work. Once the motor starts going, it goes easier. Draw goes down, and the computer's finally able to pick out that crankshaft position sensor signal. How's that for a weird one, right? Now, I will bring this up because last night's class, when I told this example, how did you get that and figure it out, right? What got you to the point of the starter? So let's think about this. We eliminated the fuel pump because I think that's where everybody would normally go on this. Well, it's a Nissan, and we're having starting problems with a Nissan. Jesus Christ, it's a freaking Nissan. What else is always wrong with Nissans that cause them starting problems? Cranky cam sensors, right? They're always freaking bad on these cars. So let's hook up our scope to our cam and crank sensor. And wow, now we see, I can't see my cam and crank sensor because I have so much noise intrusion being caused by the starter. Okay.
How do you waveform show up?
What?
What did it make a waveform? Like, what did the waveform?
Good
look like?
question.
Oh, it looks like, man, there's not really,
Go to down the scanner.
I can't really, I don't have anything close that I can show you. So basically, it looked like just voltage up and a whole bunch of noise, basically. Just pulling it off the ground. So now here's another example. I know some of you guys work on diesels out here. How many of you guys have seen the Ford 7.3's crankshaft? I think they call it a camshaft position problem, but it actually is a crankshaft position sensor on those trucks. Where the customer goes and starts his truck, drives it to the store to get something, and comes back out, and his crank no start. Gets towed to your shop. Crank no start, what's the problem? It's the crankshaft position sensor's the problem. Well, Ford ended up having to redesign the crankshaft position sensor on these trucks because the actual problem wasn't the sensor itself. The problem was there was too much noise being caused by the starter on these, and it couldn't see where it got pulled back to ground for the crankshaft position sensor signal. So what they ended up doing was they offset the ground and put a floating ground in. And the nice thing is it went from like $200 sensor to like $27 sensor. Price went way down because they knew that they screwed up and everybody was going to need to replace that sensor. Okay? But the alternator, which is what pretty much everybody brought up, that definitely can be noisy too, right? Now, the reality of it is I don't think many technicians think about noise from the alternator as part of their diagnostic strategy anymore. You know, in the old days, you know, we had points and condensers and stuff like that. Technicians paid attention to this stuff because it caused problems like noise in the radio and stuff like that. And you can argue stuff was made better or worse back then than it is now. I personally think everything was made better than it was now. But this is something that older technicians paid attention to because it's stuff that they saw as more common problems. How many of you guys remember the last time, if ever, you tested an AC signal out of the alternator for noise on a car? Okay, one. It's not something that we think about, right? It really isn't. I'll be perfectly honest, I think the majority of technicians, even when they're at the end of their diagnostic and they can't figure out what it is, that still doesn't come up in their mind as something that might be causing their problem. But we've talked about over and over how many computers we have on cars nowadays. We've talked about how important the electrical system is on cars nowadays. Guess what? Computers don't like noise, and we have a whole lot of computers. We've got communication networks that don't like noise. So it's becoming a potential problem again. Now, I am not going to say that every car that comes into your shop that has a problem, you need to test the noise from the alternator, because I don't think that it's now a major problem that we're still seeing. But it's something that you need to keep in the back of your mind as a possibility. If you're doing your testing and things are testing fine, and you're starting to think, well, shoot, what else might it be? You might want to do this test just because it might be causing you problems, because it is important. Yes.
I will say this, and I agree with that, I haven't checked that before either, but what's neat about the little Navitor house is different from the one that you showed in the picture.
Okay.
If you go and do the complete test, which only takes a few more minutes to do, it shows you a ripple pattern.
Okay.
And, you know, if you do it, instead of just a battery test, you do a complete test, it's called. And it tests the starter, the alternator, it does all that, and the battery also.
Okay.
And it gives you, it's got a little waveform pattern with it. It tells you whether it's got ripple,
That's cool.
you know,
I don't
whether
think-
it has or not.
I don't think mine
And
did
it's
that.
something that I never, you know, like I said, I never thought about checking before, but since it's there, you know, it's something that's easy to look at.
There
You
you
don't
go. There's
take
one more reason to test all those batteries.
Right, and it just, you're right. And that's one thing I like about the little tool.
Okay. I don't remember mine having that, so you might have a different version than the one I have. The Napa one that was in the picture is the Midtronics, is who makes it.
I think that's the one.
Yeah, it's a Midtronics. There's a couple different versions of the Midtronics one, so I don't think the one that I had that, because I don't remember ever doing it. We generally did the full test,
Yeah.
because I like to sell stuff to customers, to be honest with you. So anything that it would find, I can sell it to the customer. So let's talk about this. If it is something that we need to test and we need to think about, you know, what are we looking? This is what it looks like if you're doing it on a lab scope. You can also do it on the digital voltmeter if you set it to AC. You're looking at your peak to peak, so top peak, bottom peak. This one's measuring about 200 millivolts. This is a bad one. So, our domestics, Ford, Dodge, Chevy, I'd say about half a volt, you're still fine. But our imports, our European stuff, are more finicky. 200 to 300 millivolts on those can, and if you're above that, you can start to cause problems. So depending upon what you're looking at, 200 millivolts, which is 0.2 volts, up to 500 millivolts, which is 0.5 volts, is kind of your range depending upon what you're looking at. And again, I don't think this is your silver bullet to solve everything, or that you're going to run into it a whole lot, but it is something you guys need to keep in the back of your minds as a possibility. Okay, we already talked about voltage drop testing. There's a picture of it. These are the values of what's considered maximum for the different connectors, relays, and wire when you're doing this testing. This should be in your book. And I think we all know at this point that what symptoms could voltage drop issues cause? Any symptom that we have, short of maybe our suspension problem. Okay, I don't think it's causing our suspension problem. Alright? So, let me give you another example of a voltage drop issue. Customer comes in. This is an older GM, let's call it an early 90s, because I do not remember the specifics on this car whatsoever. Customers complain. Sometimes my AC doesn't work. It seems like any time that I take my wife somewhere, my AC stops working. My response, that is an easy solution. You don't even have to pay me anything. I'll give you the answer right here, leave her at home. So, sometimes, AC stops working, it seems like when my wife is in the car going with me somewhere. So, in getting this information from the customer, that would point us towards something on maybe that side of the car as being part of it. But, okay, is it acting up right now? No. Okay, bring it back when it's acting up, right? Customer brings it back a few weeks later, it's acting up. So, do our research, find our trouble tree diagnostic in ALLDATA. Those things are wonderful. Go through it, get to the result of replace the AC control module, the head. Okay, call the dealership, it's in stock. If they stock it, it must be no problem, right? Okay, order it up, put it in, fixes the problem, ship the customer down the road. Working fine now. A few weeks later, comes back in, AC stopped working. Still not working at this point in time. Get rid of that wife yet?
Freaking
So, go through our testing procedure again, and what's it point us back to? It points us right back to the AC
Compress.
control module. Well, pretty sure it's not the AC control module at this point, right? So now we need to do some more
draw tests.
looking and learning, because no data really isn't helping us with their procedure. We need to figure out our own procedure. So we do some more looking at wiring diagrams, and we end up figuring out that there is a communication network that this module is connected to. And one of the things on that communication network is the passenger side door module, which is, a really expensive name for a window switch, right? So, there's actually a master-slave relationship in this network. The door module is the master, and if it doesn't work, nobody else wakes up on that network. I don't know why they would make the door module the master, but yeah. So, that's in the door. And what does the wife have to do every time she gets in the car? Open the door. Right? A whole bunch of wires that run between that door that get right? Voltage drop tests the circuits, end up finding that we have a bad wire where it leads from the car into the door, basically. It's a problem. that's a really pain in the butt. And you gotta figure at that point, after we put that module in it, we're married to it, so we have to figure it out, right? You know, and that's just one of those, yeah, and you gotta figure it out, because the information's not there to help you in no data. Their trouble tree is a useless load of crap, because nowhere in it did it say, hey, check the network and make sure that, you know, you have communication and all this stuff is working. No, it didn't tell you that. And that brings up, how important is communication in cars nowadays? Oh my God, everything's a computer, and how do they talk to each other? Communication lines. I'm almost 100% positive that in December we're having a communication class here. I could be wrong, but I'm pretty sure. So I'm not going to get too far into that right now. But again, figured it out by figuring out where we might have a problem, voltage drop, testing the circuit, and boom, we have voltage drop issues. Okay, let's track it down and figure out where it is. So what kind of things could cause it? That could definitely cause you some voltage drop problems. So this is the point where we've done our testing, we know we have voltage drop between this point and this point. Now we can take some connectors apart and look and see if we have some problems in them, right? Diameter of gauge of wire. So you guys that work on BMW, you guys have the tail lights that burn up, and then there's that like 8 to 10 inch wiring pigtail that comes off of them that burns up too. But BMW was smart enough that they made it an 8 to 9 inch pigtail so you could replace the pigtail too. Why didn't they just design it so it wouldn't melt if they knew it was going to happen? How stupid is that, right?
They get to make money selling parts.
Distance between the power source and the load, faulty wiring, faulty switches, connectors, current surges. Another thing that I like to bring up at this point in this class is connections. Connections over time build up what I best describe as like a film or light corrosion. It's not something that you're actually going to visually see. It doesn't look like that. But think of it as almost like a protective film. It protects it from conductivity actually working. So where I most see problems with stuff like this is airbag circuits, throttle position sensor circuits, things like that were very minute, oxygen sensor or wideband O2 sensor circuits. Things where very minute changes in current can cause you problems, can cause you codes where, man, I freaking tested everything. Everything tests fine. I cannot get rid of this code or get rid of this problem. So there's a product called Stabilent 22. You guys have all heard of this? Just started using it. Okay. You guys that haven't heard of it yet, it's called Stabilent 22. What I can best describe that it does is it drills microscopic holes through that layer that builds up to restore conductivity through the connectors. This isn't necessarily a silver bullet that's going to fix all of your problems, but you know, it's about $75 for a little bottle, but you don't use a lot of it. My little bottle, I think I used about half of it in 5 years. And there's no reason why not to throw it on those connections where, you know, a little bit of extra resistance might cause you problems to help with those. Have you had it fix anything for you yet?
I used it on throttle body connectors, accelerator position sensor, like
EPS.
crank sensor, oxygen sensor connectors. Anything that is a signal.
So many of you guys had it fix a problem that you weren't able to fix? Not yet? Airbags is the big one where I've had it fix problems for me. Airbags is definitely the big one where I've had it fix problems for me. All right. Scan tool diagnostics. How many scan tools do you guys own? As a shop, how many different scan tools do you own? 3. 3? What do you guys?
4, 8, 4, 5,
No,
Manufacturing?
all different scan tools.
Oh, you're right.
I can take an Autel, and maybe it won't communicate, but my Snap-on will.
Oh, yeah.
And I had a whole bunch of OE scan tools. I had heavy-duty scan tools. I worked on Isuzu and Mitsubishi box trucks, MPRs. And oh man, the worst one was the MPRs. I got so freaking tired of the exhaust having a problem, setting a code, clearing the code, and the stupid exhaust warning light was still on, and the only way to actually clear it at that point, you had to reflash the module. And then you gotta send it to the dealership, and they're 2 weeks out before they can get to it. I just bought the freaking scan tool, and I actually got the scan tool for like $1,000, and I got the Chinese version. I have the Chinese version. So, I had 15 scan tools. I had tons of scan tools. Why? Well, because I had worked on everything. I worked on everything. We were the shop that everybody that had a problem sent their cars to when they couldn't figure it out. Okay, so of all the years that I've been doing this, and I've been doing this for about 20 years, even though I know I look pretty young, I'm almost 40. I've been doing this for about 20 years, and in all of those years, I've had 2 cars that I wasn't able to figure out. One of them, to this day, I have no idea what was wrong with it. I just gave it back to the customer and I said, I give up. I even sent it to the dealership and they couldn't figure it out. Sent it to another dealership, they couldn't figure it out. I said, I'm done. The other one was a stupid Hyundai Sonata, and I knew what it was doing. I knew exactly what the problem was as far as what it was doing. I just had no idea what it was doing, the stupid thing. It was taking its fuel trim at a cold start and saying, I want 8 milliseconds of injector on time. So it was just flooding the crap out of that thing. Disconnect the battery, touch them together, clear everything out, fire up, and it would run great. Try it, and you started for a second, and it would, the next time you started it, it would do it again. I disconnected sensors, and no sensor that I disconnected would make any difference. I got to the point where I gave up. With bad fuel. Bad fuel. Don't know how it knew it had bad fuel. Fuel trims looked fine. To this day, I have no idea. But some engineer told the dealerships that if you have this problem come in, the first thing you need to do is check the fuel because we're seeing a problem with bad fuel. So they knew it was a known problem, and sometimes dealerships know stupid stuff like that that we don't